Alright, hello. Cool. I am here, and, guess who's an idiot? That'd be this one right here. Yes, I'm an idiot. So... no. It is not you, Neo Kenobi. And also welcome to my stream. So let's see here. Let's go into Streamlabs. So I've been doing. I figured it was you. Shh! We can't break the fourth wall. We can't let the other peasants know. So I've been trying to like plan everything out and execute from there. But the problem is that I'm not that good. I'm not experienced enough in order to be able to pull that off. So what I've decided to do instead, Am I even gonna actually do the thing? Oh dear God, come on. I need to do that. Was that it? This is a little bit frustrating. Hold on, I'm trying to make sure that I can do things. Okay, so that does work. Cool. And I'll do... Alright, that's not the right one. There we go. I'm not gonna hack into a dial-up modem. I don't even have access to it. Yeah, remind me later. I don't care. Alright, so, yes, I have been an absolute dumbass. So, let's go over to Visual Studios. Make it so I can still see what it is that I'm doing. So what I've decided to do is, instead of trying to, figure out exactly how everything would be set up, I'm going to instead write a test application, right? And just write it out how I want it to be, all set up and everything, so that and then just as I do things, go back and implement it, right? So one of the things, so I have a lot of pretty boilerplate stuff here, right? I just have, I know I need an entity thing, I need a component thing. Yes, back to forward design is a valid strategy. Like both ways are perfectly valid. You can either go from the bottom and work your way out, or start from your endpoint and work your way, back to the beginning. It's kind of like the two different ways of solving a maze, right? You can either start where it says start and then fumble your way through, or you can start at the end and work your way backwards. And depending on the maze or depending on the problem, one method may be a lot easier to navigate than the other. So one thing is that I want to, so let's quickly walk through what I have so far, right? So I want my int main, right, to, like, this is it, right? Like, this int main, like, this is finished, right? Like, this is all that I want in the main, in the int main. And for anyone else who doesn't already know that, you know, this is your entry point, this is where your code starts. The executable specifically looks for this, for a function that returns an integer named main with this spelling and takes no arguments. It can take arguments, there's always a passing that in, but that's beyond the scope of what it is that I'm going to be doing. Right, so this is the entry point. And then in here I create a game of class tester. And then I run the game, right? That's all that the main is going to do. So where is this tester, right? Well, the tester is a class that inherits from the game class. Okay, well then how do you do stuff with it? Well, in the constructor, I want you to set a bunch of different, you know, things, right? Because here you'd also have, you know, you'd say set window width, set window height, set input methods, right, etc. Right? You'd be doing all these things, and then here, right, and this is being stored inside of a. This is just being stored inside of a, like a static struct, right? And then you'd create the engine, and you store that internally into this game. This is technically this engine is equal to that, but this is not necessary. I'm just going to leave that in for visual referencing, knowing that that's exactly what's happening behind the scene. And then you'd also say this push, right? Alright, so you do that, and then this, you know, creates the engine. And here we want to push scene 1 onto the scene stack. And then what about scene 1? Well, scene 1 is up here. Alright, that's as far as I really got. So let's go back to, let's back it up a little bit and take a look at what the scene stack actually is. It is an array. I'm just making it 1024 because I seriously doubt that you'll have many more scenes than that in a single stack. You may have many more scenes than that available in your game. But as a singular stack, it's very unlikely that you'll have more than that. You probably won't have more than 5 at once. Maybe even fewer than that, right? For most games. So this is far larger than it needs to be. You'll probably get away with it being, you know, a singular byte, right? 256. But 1024 is fine. I can make it a 16-bit integer if I really wanted to. But the stack head starts at 0, and then you have two templated things here, right? And I'll go into the whiteboard and explain how those work here in a little bit. And here's also the config struct, which is static. The reason why it's static is because even though the struct is not static, all actual members, all these guys are static. So you have, command line, you have your OpenGL, and you have your Vulkan. Also, as a fun fact, this whole setting up a struct and then implicitly using that struct to initialize an engine or something like that is also how Vulkan handles everything, right? This is how Vulkan works, actually, is you set up a struct and then you initialize it, and it just uses everything from said struct to initialize its internal stuff, right? And as you notice that all these are static, all these are all these are static and stuff, so there is this sense of global permanence. So you would set things up and then initialize it, and then you'd have to set things up again individually, and then set it up again. But usually you'd only have one engine at a time per game. So there's not much of a reason to reinitialize the engine. There may be for some reason, I don't know. I don't know what kind of crazy things y'all kids are going to be up against. So back to the stack, right? This stack, right, and that's what's happening here, is that you're putting scene 1 onto the scene stack, right? So let's hop on over to the whiteboard. Are we? Oh, come on. Come on. There we go. Let's hop on over to the whiteboard. So the way that the stack works is that it is just did I not? Oh, I plugged in the wrong USB cord. That's just power. There we go. Well, I mean, I guess my VTube thing can just exist there, I guess. I'm just gonna move that for myself. There we go. So, let's talk about the stack, right? So what we have is, we have a thing here, right? And then we put onto it, scene 1, right? So whenever we do anything like rendering or handling anything that the scene is going to be doing, any objects within the scene or any inputs or anything like that, which means that the scenes themselves might have to handle there might be independent. Yeah, there might be independent. I don't know. We'll see. So we have the scene here, right? Right. Scene 1, and then like anything like input, it goes in from the top down, right? In this case, there's only one thing there, so it doesn't matter. But if we push on, S2, push on, S3, 3. You could even have things that are like differently shaped, so we can have, you know, S4, which doesn't listen to as many things. And you can have, you know, S5, which listens to even less. So you can have things like the input is over here, right? So it hits scene 3 first and consumes it entirely. So nothing goes down past scene 3 for the input. Let's say you have like rendering, right? Rendering may need, now rendering is a scene system. Yeah, I know how to use the damn shit, right? So render is a bottom up, is a penetrating bottom up system, right? Which means that it goes through all of these to go through. You could have, you know, some other thing that is top down, right? Anything that's, you know, anything that's top down is consumed, right? Anything that is bottom up is not consumed, right? And this is an important thing to keep in mind, because there will be 2 different types of, you know, scene systems, right? So, and now something to keep in mind about, you know, scenes is that, oh, and can you hear me? Can you hear me just fine, hopefully? Right, so a scene is just an entity. Okay, cool. I'm always super paranoid that I'm not loud enough, or the music's too loud, or I can't be understood, or whatever. So is essentially just an entity whose components are entities, right? So it is just an entity with hard points, right? Things that you can attach entities onto, right? And like I said, there are 2 different types of scene systems, either top down or bottom up, where, you know, the bottom up are not exactly consumed. So you'd render scene 1, and then you would render scene 2, and then you'd render scene 3, scene 4, scene 5, etc. Things like that. And then you would do things like you would consume input. So the input might miss scene 5, scene 4, but hit scene 3, or input may go in here and hit scene 4 first, you know, passing scene 5, hit scene 4, and then get consumed. It might go all the way around scene 3 and hit scene 2. And what's really cool is that you can pop these scenes off as well, and then you can like bring them back on, right? That's the cool thing about a stack. I know this looks like an absolute nightmare, absolute mess. So that's the scene stack. One thing that I really want to do is the component container. One thing that I really want to go over is the component container. Yeah, render the level, then render the options menu. Input is most likely eaten by the options menu. Exactly. Yeah, exactly. That's a perfect example. And both the level and the options menu are both scenes, right? So internally, right, you have, you know, you can give them better things, like, you know, you'd have your stack and you'd have your, you know, you'd have your level. And then here, you'd have your UI. And both of these are just scenes, right? So you can even have a UI with physics and things like that, with physics objects in the UI or whatever, right? And then you can push onto it, you know, options, right? And then once you close options, you pop it off the stack, right? That's a perfect example of why you'd want a scene stack. And it's also what Pokemon used. They, instead of like a scene stack, they called it what is it? Is a state stack, where you pop different states on. In this case, the states are being replaced with scenes, just so that you can have a little bit more control over exactly what is going on. And then you can overlay and lay a bunch of stuff onto it, right? So where was I? Let's go back to 100%. Right. Container. Right, component container. So the component container is that I want to have position, right? And I have a thing here, okay? And then as I add in things, right, I basically have a head here, and I say, you know, I add one in, and then this advances, right? And this advances down to here, and you add something here, right? And then it advances. So far it's very similar to like a stack, right? You add things here, right? And then you add more. Hey, Gaming Forever's 65. Glad to see you hit my stream. How you doing today? And you go in here, and you go in here, and you go in here. I feel like I could actually do this a little bit better for my own OCD stuff, right? So you'd have your first one in here, next one in here. You can keep adding more and more position, more and more entities that have position components, right? But then this one is like an entity and it gets destroyed, right? So you know, the head is currently here, right? I'm doing all right. I'm doing all right today. Kind of going over some data structure stuff here, right? So the head would normally be right in here, but if you want to iterate through all this, right, you don't want to be having these jumps. So instead, you would, when you deleted this guy, right, when this guy was deleted, you would kind of make a phantom pointer here, right? So the next item that needs to be created would be added in here. And then it would remove this one because there's no more. And all right, because it's no more, and then it'll keep going. So how do we do this, right? So one thing that we can do is, going back to the whole stack idea, is that when we delete an object, right? This is, you know, 0, 1, 2, 3, 4, 5, 6, 7, 8, right? What we would do is we would pop that position onto the stack, right? So we know that 2 is the last thing that we deleted, right? And then we can delete 5. So we'd put 5 here, and say we deleted 0. So we'd put 0 here, and say we deleted, I don't know, 7, right? And this is pretty bad, right? But as we create new ones, right, we know, well, we have a stack, right? So we'd take that, put the next one in, so we'd go to 7, we'd add the next one in there, then pop the stack. Next one is 0, so we'd add one in, and we'd pop the stack. Next one, you know, and then we could delete 3, right? Add that onto the stack. And then when we add something in, we just put it there, pop it off the stack, add one on 5, add one on 2, and then delete it. And this is fine for the most part. It would be better if there are ways to go through and reconsolidate things every now and again. For instance, like, say we have, you know, a bunch of these, you know, we have 1, 5, get rid of 7, you know, we get rid of 3, right? What we could do is we can reconsolidate, right? So what we would do is we would move the head back, right? And then we would put this here, right? Well, first what we could do is we could reorder, right? We would reorder the stack, right? So we would go 7, 5, 3, 1, right? So we would move here. We would, right? It was here, right? We would move it up to here, and then we would remove this one. Go to this new stack and insert it there. Pop it off the stack, right? And we'd also delete this stack, right? And then we would move this one here, right? We would see that it is a null pointer, right? So we would move it again. Notice that there's something there, so we pop it up, and we take that stack, pop the stack, move it there, right? And then we would move it, right? Notice it's null pointer, move it, and then now we see that there's something here. We take a look at this index and we compare it to this index, right? If this is less than that, then we're done, right? That's how that data structure would work. And then we would just do a little bit of cleanup, delete that stack, reinitialize this stack to 0, clear up all of our pointers, and then increment our head. Move our head back up 1. That way we can reconsolidate things if we need to. I'm not sure if I'm going to, right? Yeah, it's drawing out how everything works is super important, and you can see why keeping everything consolidated and compressed is a very good thing, right? So if you have, and you can find out like how bad things are just by how long your deleted stack is, right? So you can do things, and the problem is that moving something is very, very expensive, right? Because let's take a look at what is necessary to move something, right? So say we're looking at this, right? And what we want to do is move this here. What does that actually entail? Well, we can't just move the information there, right? Because we have some, you know, let's say we have the player, right? This is the player, right? This is the player's position, right? So if we want to move this, well, then we have to go tell the player, hey, position has moved, right? Oh, but it's also, but the player also has physics, right? So you also have to tell, you know, physics, hey, this position has relocated. Oh, but it's also being rendered, right? So you have to, you see what I mean? So you want to limit how many times you actually reorder things. Otherwise, you would just reorder everything as you go, right? So you would want to very specifically limit, and you'd only really do it if it's like super necessary to do it. Like, it is a possibility, but it is a very costly operation that you'd want to do as infrequently as you can, right? Because otherwise it just won't work out. Because there's a lot of things, and there's a lot of places that things can go wrong if you forget to do stuff, which can be quite a bit of a problem. So yeah, so let's take a look at what we want our test scene to do, right? So those are some things that we are going to want to have, and then there's also scene stacks. No, there's also scene systems, which they might have their own stuff. Yeah, like a lot of computer science in general, and same thing with mathematics. It's not, you know, computer science isn't about doing the typing, you know. This isn't computer science. Hold on. Right. This is not computer science, right? This is coding. This is programming. This is coding. This is coding. You know, all this is coding, right? Computer science is taking your problem and breaking it down to the point that your problem becomes trivial. And the same thing goes for mathematics. You have a very complicated problem, and you just break it down into smaller and smaller pieces until each of those pieces are trivial to solve, and then you just run all the solutions together until you get your result. Right? It's all about transformations. taking a problem and applying operations onto said problem until the problem is not a problem anymore. In both mathematics and computer science, that's what it means to be a software engineer, and that's what it means to be a programmer, that's what it means to be a mathematician. Is understanding what those transformations are and how and when to use said transformations in what way. Right. So yeah, we have the stack. And another fun thing is that you can tell how big a stack is just by taking a look at where the stack head is. Usually in actual in like how your function stack works in your PC works differently. It goes from the end and it works backwards for whatever reason. I think it's because the information is not predetermined, right? So it's a lot easier to figure out where the pointer is, because then it'd be a pointer to how big that slot is, and then you can go from there, and that's what dictates how the head moves. So since I know how big, since my stacks are of a predefined size, I can start from the beginning and go to the end, which simplifies a few other things. It simplifies some things and complicates others, but the things that are complicated don't really matter, right? So I don't have any, it's a very strictly typed stack, so it makes more sense to start from the beginning and work towards the end. So you know how much of the stack is filled and all this other stuff and how large it is and a bunch of other things you get for free because of it, right? So that's why my stacks are in the opposite order from like a quote-unquote real stack. So let's see here. So we have the command window and we have the scene, and what do we want in the scene? We want the scene to have, I don't know, an entity that prints a thing, right? So we could have because I think I could do something along the lines of like scene1 dot add entity yeah, okay. Yeah, because it's not doing a thing. Well, actually, can I even do that? Like, is that a thing that I can do? So I'm not sure if I can. Because I might be able to. Or do I need to declare the scenes in here? In the tester? That might be a thing. Because the game might just have a list of scenes, right? As well as a scene stack. But it might be a little bit difficult because, like, if I can have this kind of code be outside of a function, then it'd be very nice, right? Well, let's try something. Let's go into scene and have, let's just do, void add. We'll just do that just for shits and giggles, right? And then we'll just create definition add and there. Oh, stop doing that. There we go. Where'd you go? Scene add. Okay. Print F. Here is the scene add function. Right. Because the only other thing is that it could be, because I might have to do another thing like this when it comes to scenes, which is fine. I think that's fine. Right. But I just want to see if these kinds of things are going to actually work. Because can you please, for the love of God, stop doing that? Right. Because otherwise I could do scene 1 dot add here. Yeah, no, it's not going to let me. Okay. So these are actually going to be, so yeah, so this is going to have to be a new scene 1. Alright, which means that and these are going to have to be classes. Scene 1, public scene. Right. So these are going to have to be classes, right? So I can do public, right? And then in here it'd be scene 1, which I'm not super happy about. Right? Because I could do something along the lines of add entity. And then here it'd be more entities, and those entities are gonna have to be Jesus Christ, dude. Okay. Because I'm gonna have to do the same thing with entities as well. But everything is strictly typed, so it's fine. Because here I'm going to have to do a class test E, public entity. Test E. Right. Because the add function is you're going to be adding things, so this is going to be a template. I mean, I guess I could just do class T add here, and then in test E. Well, yeah, this is the tester.cpp, which is not the one that I want to do. I want to do it in the Foxfire engine. And here it'd be template class T void scene add. and then here it'd be template here, and then here it will be entity here. That's fine, and then here it is actually the pointer to entity E. So in here, I'm also going to say pointer T. So T, well actually it would be T pointer. Right. T, so it'd be T entity pointer E. There we go. Cool. If either of you have any questions about what it is that I'm doing here, or if this is just typing up a bunch of magic, just let me know. Feel free to pipe in and interject and see how it is that I'm doing. If you want any explanations on how C++ does things, like why am I using a pointer instead of a thing, it's so I can do stuff to it. That's why I had to do stuff here with, you know, both push and pop. Yeah. Okay, so when you add it, yeah, I could just do that. That's fine. Here's the scene add function. Cool, that's fine. I'm okay with that. Add entity. This is the. Oh yeah, I'll do a new test E here. Yeah, because I can do that. Because the new keyword, I know enough of it that I get the gist, but also my ADHD meds have worn off for the day. Yeah. Yeah, ADHD meds wearing off. Yeah, that'll kick your ass. That'll kick your ass real quick. I have my ADHD meds have worn off about 10 years ago. Yeah, I've been off my meds for like a decade, if not longer. 12 years? 2011, 2012 I stopped taking my medication. I think so, something like that. Sounds about right. Yeah. Yeah, there's. I mean, it's just as long as things mostly make sense, I'm happy. But if anything pops up and becomes like really interesting to you, then yeah. Yeah. Yeah, 100% notice when I failed to take it, things get much harder to, much harder, yeah. Early on, it was very rough. It was very rough, and like for the first, you know, couple months to a year. And I quit cold turkey too. So it was a very rough time. But I'm also happy that I did, because there was absolutely no way that I was going to be able to afford it. And I just kind of, I don't know, learned to deal. I guess I'm one of the lucky few that kind of half-ass grew out of it. Kind of, sort of, not really. Or at least found ways to still mostly function without them, so it's not necessarily for everyone. If you have the luxury of taking ADHD medications, fucking take them. It makes your life a lot easier. It makes your life a lot fucking easier. It's rough without them. Like, I'm happy that I can function as well as I can without them, but some days I wish I could. I can still tell that it would be nice to have them again. I'm sorry. Yeah. Okay, let's see here. What was I doing again? Oh yeah. It's going to do a new test E, and then let's not deal with that yet. Let's just do a build. And then I'm going to... Okay, that worked. I'm also going to double check and make sure that Streamlabs is actually finding it. Yes, cool, it does. Engine here was the add function, cool. So yeah, that does capture. So that means the engine is initialized twice. Oh, yeah, and the reason why the engine is initialized twice is because in here, right? In here it is declared. And as soon as it is declared, unless it was a pointer to an engine, as soon as it hits engine, it'll create a new engine. And then it does it again in the tester game class because of this here. So I love you. All right. So, just weird C++ things. Okay, so it is adding, yeah, except it's not actually doing anything, right? So we need to actually implement the add function. Scene add entity. So what does that actually mean, right? What is the scene going to have to do? The scene is going to have a protected STD, well, yeah, STD vector. It's a very unfortunate acronym. Entity. I guess it would be entities. Sure. And then that will immediately get initialized, so I don't care about that. So in the add, how was I doing things in here? Also, I'm a little sad because I was doing some serious Carmackian abusive syntax at one point. but I'm sure I'll have plenty of opportunities to do that later. You know, I had a real clever way of doing things, like using, I had a map where the key was a function pointer, and then that was pointing to like the data necessary for said function. Yeah. Which I found which I thought was really, really cool. But that's not a thing anymore. So I have the entities in the scene. So the scene entities. And I'll be